Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics, and today we will start our fifth lecture, that is the unit of Introduction to Engineering Econometrics. And today we specifically highlight the forecasting issue. In fact, in the last lectures we have discussed details about the engineering econometrics, the kind of requirement, the kind of structure, and the way we will analyze the problems, and then discuss the issues and point out the objectives and the kind of insight we are expecting. And the end part of this particular process is nothing but called as a predictions and followed by forecasting. So, we should know little bit about forecasting before we solve any kind of engineering problems as per the particular requirement. So, let us start with the basic contents about these lectures. So, first of all, what is all about forecasting, and then we will discuss something related to objectives, methods, and then steps of forecasting. So, how to start the particular process and then how to conclude with the kind of requirements. So, there are there are n number of ways we can define the term forecasting, and specifically it is a kind of difficult and complex term. So, without any kind of quantitative structures or something like highly qualitative structure, you cannot do some do something called as forecastings. So, let us see how is the kind of forecasting altogether, and what are the steps we have to follow to do the forecasting for a particular engineering problems. So, typically it is completely said difficult to make predictions especially about the future. So, forecasting comes into the limelight, and a forecast is a prediction of some future events or the events which you need actually to justify the facts for the growth or something kind of the sustainability aspects of any kind of engineering problems. In fact, it is the process of making predictions of the future trend based on the past and present data, and most commonly by analysis of trends. So, there are different levels of structuring. What we have discussed earlier, the kind of engineering econometrics can be of two types, something called as descriptive econometrics, and then we have something called as predictive econometrics. So, in both the cases it is the question of use of data, and typically we have already discussed the kind of data, the kind of process. The data structure is like that, we may have a cross sectional type, we may have a time series type, then we may have the club of these two called as a pool data or panel data. And in fact, whatever ways we can represent the data or gather the data for the kind of investigation about a engineering problem with the intention of prediction and the future forecasting. So, the issue is that we technically use the past data, the past information, and the kind of present data, present information. With the help of past and present data, we like to predict the future requirement. So, that is the basic background about the forecasting. So, what are the ways we will use the past data and present data and then predict the future requirement. So, that is the kind of learning which we will have from the structure of forecastings. So, let us see how is the kind of forecasting. So, in sum, forecasting is a kind of decision making tool used by many engineering problems to help in budgeting, planning, and estimating future growth. So, whatever may be the kind of problem area or any kind of engineering. So, ultimately when we like to investigate, then the major requirement, for instance typically the kind of engineering econometrics requirement, what should be the sustainability aspects altogether, and then forecasting come into the picture. So, we will see how is this structure of past structure altogether and the present structure, and with the help of past and present we have to build the future path. So, this is the basic requirement, and sometimes it can be called as an attempt to predict future outcomes based on past events and the kind of engineering insight. So, if you summarize altogether, then it is nothing but look into the past information, present information, and see what should be the trend for the future requirement. So, whatever may be the problems, so we have to do the kind of forecasting for the future requirement. So, the kind of forecasting may be very simple, may be very complex, it depends upon the nature of the problem. For instance, the nature of problem may be very complex or may be very simple. For instance, it may be a bivariate structure, it may be a trivariate structure, it may be a multivariate structure. So, if it is a univariate or bivariate structure, it is very easy to do the kind of prediction and forecasting, but in the case of multivariate problems, it is not so easy to do forecasting very easily in fact. So, in that context, some kind of quantitative structure or the kind of technical procedure you have to follow to do the better forecasting as per the future requirement. So, in that context, let us see how is the kind of requirement. So, the basic requirement of means basic objectives behind this forecasting is to fix the appropriate the rule of forecasting, knowing the qualitative methods of forecasting, and knowing the quantitative methods of forecasting. Then we have to know the structure of forecasting under cross sectional modeling. Again we like to know the structure of forecasting under time series data or time series modeling. Similarly, in the case of pool data and panel data, the kind of forecasting rules. So, at the end we like to know the forecasting error, how to assess the forecastings, and then we like to see the accuracy of the forecasting. So, that means altogether it depends upon the kind of data structure altogether. So, if you have a cross sectional data, what is the kind of forecasting rule. So, if it is a time series, what is the kind of forecasting rule. Again, in the kind of pool or panel, the nature of forecasting rule. So, ultimately in each case we have some kind of strategy to measure the accuracy of forecasting. So, there are certain tools which can justify whether the particular forecasting with the help of past data and present data are perfect or not. So, the accuracy level will help you a lot to know the the proper structure of forecasting or the good forecasting you can say. So, how is the particular structures we can get to know in details here. So, suppose we all together get to know the kind of forecastings in the context of data structure, but ultimately how is the kind of forecasting, it depends upon the kind of methods and the kind of problem structure. For instance, if a particular problem is very structured, the decision variables are identified, the data are already available against each decision variables, then it is somehow very easy to do the forecasting, and then you can measure the forecasting accuracy and finally fix the forecasting structure. But sometimes some of the engineering problems is so complex or something like that. So, you may not know what are the exact decision variable through which you do the forecasting, and sometimes you may actually know the decision variable structure, but unfortunately you may not have a information to read the pattern and then do the kind of forecasting. So, that is how in the methodological so far as methodological structure is concerned, we have two different methods. One is called as a qualitative methods of forecasting, another is called as a quantitative methods of forecasting. So, we have a couple of methods under qualitative structure, and we have a couple of methods under quantitative structure. In fact, quantitative structures you need hardcore mathematics and statistics to do the kind of forecasting, and that too on the basis of past data and present data. But in the case of qualitative forecastings, we may not have actually a clear cut past data or past information, and sometimes you may not have the understanding about the decision variables. What are the decision variable through which you can do the kind of forecasting as per the particular engineering requirement. But both the problems are different, and the it's completely situational aspect. Depending upon the kind of problem, depending upon the kind of situation. So, you have to apply a particular methodology and then do the kind of forecasting. So, technically as a engineering students, you should know what are the methods under the qualitative sides and what are the methods under quantitative sides. So, in the case of qualitative side, you may not have a proper information. So, the first hand idea is to have the proper information through a particular mechanism, and then you have to follow the path of forecasting. But in the kind of quantitative methods, so assuming that everything is in a structured way, so that means the decision variables are known to you, the informations are readily available, then what is means what are you supposed to do is you have to just pick up a particular technique, and then on the basis of data and the decision variables, then you do the kind of forecastings. So, let us see what are the methods under the qualitative structure and what are the methods under quantitative structure. So, far as the qualitative methods are concerned, the first structure is called as expert opinion, and then we have market survey. Again, third method is called as a Delphi technique, and fourth method is called as historical analogy, and then the last but not the least called as grounded theory. In all the cases, this it's a completely more situation where the decision variables, maybe decision variables are unknown. If decision variables are unknown, then forget about the kind of information requirement. And in the second case, you may have the structure of decision variable, but the informations are not available to you. So, what is happening means in general, qualitative methods of forecasting is a situation where you do not know how to analyze this particular engineering problem and do the kind of forecasting. So, what will you do? You put this kind of engineering problem in front of group of experts or group of persons who have excellent knowledge on this aspect, and then ask them to discuss each other, and on the discussion mode you can pick up some of the components which can be in future can be treated as the root making for the decision variables. Then once you know the decision variables on the basis of their discussion, then you think about the kind of collection means information collection behind these decision variables. So, most of the instances in the qualitative case, decision variables are not known. So, with the help of experts and with the help of knowing persons, we can get some kind of information which can be treated as a decision variable and to analyze the engineering problems and do the kind of forecasting. So, whether it is a kind of market survey methods or Delphi technique or historical analogy or the kind of grounded theory, more or less the mechanism are very much same. So, it is you to discuss among the groups and then find out what are the decision variable through which you can analyze the engineering problems and then do the kind of forecastings. But in the context of quantitative methods, we have different methods altogether. So, we have the cross sectional kind of forecasting and time series kind of forecasting depending upon the data availability for the kind of decision variables. In simple language, in the case of qualitative structures, so the decision variables and the informations are not readily available, but in the case of quantitative methods, decision variables and informations are readily available. In one situation, if decision variables and information are not available, how to handle the situation to solve the engineering problem and do the forecasting, and in another situation your decision variables are known and informations are available, then you have to find out what are the techniques through which you analyze the problem and then do the kind of forecastings. So, technically if you club these two, you start with the kind of things like that. Sometimes some of the engineering problems like that you can follow the first qualitative pattern, then you can move into the quantitative patterns, because in the qualitative pattern you may not have information, you have to gather information and do the forecasting, and in the later stage you have a decision variable information and the kind of data, then you do the kind of forecasting. So, the understanding is like that if you have no decision variables, you cannot have the data, and once you have decision variable and you have the data, then you can do the forecasting, but you can do better forecasting if you know something more kind of structure or more non techniques, through which with the help of technique you can do better forecasting, because when your problem is very complicated and very complex, it is not so easy to do the forecasting manually or simple way of doing the structuring or restructuring to come with a kind of solution which can address your engineering problem. So, that is how it is better to know both the qualitative structure and quantitative structure and do the kind of forecasting as per the requirement of a particular engineering problem. And now let us go with kind of methods of forecasting, and in the methods of forecasting what we have already discussed, it is kind of qualitative structure, but these methods are specifically under the quantitative structure. In the case of qualitative structure, there is no strong mechanisms or strong techniques through which you will do the forecasting. It is the kind of discussion modes, something related to group discussion, and then on the basis of discussion you have to come with some kind of decision variables informations and the kind of information you can gather among the decision variables, and then address the engineering problems and do the forecasting as per the particular requirement. But the hardcore task is to know the techniques against the quantitative methods. So, here some of the techniques are very simple and some of the techniques are very complex. So, again you should know both the simple techniques and both the complex techniques in order to address the particular engineering problems, because knowing the simple and complex, you may be in a position to pick up which particular technique is very useful for addressing the engineering problem. So, in the one side the kind of division is cross sectional forecasting and time series forecasting depending upon the data structure or data availability. And then so far the types of models are concerned. So, we have a causality forecasting models, and then smoothing models, and then finally, we have a time series models. In fact, under the time series models or the time series modes of forecasting is very interesting, very complex, and very tough sometimes you can say. For instance, some of the models are or some of the techniques are very simple one, and some of the techniques are very complex one. It is sometimes without any strong mathematical knowledge or statistical knowledge, you may not understand this technique and you may not use this technique. For instance, under the time series modeling, so you have a called as scheme called as autoregressive schemes. We have a moving average scheme. Again, we have the club of these two, that is called as autoregressive integrated moving average scheme, vector autoregressive schemes. Then there are schemes called as volatility modeling, like autoregressive conditional heteroscedasticity, generalized autoregressive conditional heteroscedasticity. So, that means what I can say that under the time series modeling, so there are so many simple techniques or advanced techniques to do the kind of forecasting, and very simple understanding is that in the case of time series data, the way of forecasting is very easy, and it is more appropriate, in fact you can say, because it maintains a kind of continuity. For instance, let us say monthly data is available from 2000 to 2015, and then you need to forecast for 2016 and 2017. So, that means monthly it is actually it is in a kind of trend trend way, then you just actually read the trend and then you can do the kind of forecasting. But in the case of cross sectional data, it is not so easy to just follow the trend and then do the kind of forecasting. Just like you can just read the patterns and then extend this kind of pattern for the future requirement, which is very easy in the case of time series data, but it is not so easy in the case of cross sectional data. Again, after doing the forecasting structure, so then you have to check the accuracy, and so far as the accuracy checks is concerned, so in the case of time series modeling, it is very easy to do that, but it is not so easy in the case of cross sectional modeling. For instance, in the case of time series modeling, so whatever data you can have, so you can actually divide into two parts. For instance, out of say 150 data, 80% of the data you can do the model development and model diagnostic check and everything you fixed for the future requirement. Then next 20% data you can keep for validations. So, that means ultimately when you have actually original data, the level of reporting may not in a kind of continuous way. So, it may be ups and downs. For instance, it may be like this. You will see. So, let us say it is a some 100 observations are there, and all observations will be like this. So, you can just put a trend like this. So, now the way of forecasting is that you apply some kind of technique and then find out a trend line. Then the way of forecasting simply is that extend this trend line like this. So, now once you confirm that this trend is okay, then you can just extend this line up to this much. But now, in order to know whether this line is perfect or not, what will it do in reality? So, let us say this is actually 100% of data. So, you make it 80% for the model building, and then the rest 20% you can keep for model validation. So, that means you read this data, develop a model and find out the trend line and extend this trend line up to these ones, but actual data are already available here. Then you see the actually trend line, and that means it is called as a forecasted line, and the actual data points. So, the forecasted line and the actual data point, if you find there is no big difference, so that means the accuracy is very high. So, in that context, so you can go ahead with the kind of forecasting, and this is much better way to do the forecasting, and it is possible only when you have a time series kind of structure. But in the case of cross sectional, it is not so easy to check the accuracy of forecasting, because the question is what kind of cross sectional unit you have to reserve for the accuracy check. But in the time series, which is possible, because you are actually moving from extreme past to present. So, by default towards the present data you can keep, or you can reserve for the kind of accuracy check. So, which is not so easy in the case of cross sectional modeling. So, that is why time series data means doing forecasting by using time series data is very easy and very perfect compared to cross sectional, using cross sectional data for the kind of forecasting, and that too for the engineering requirement. That does not means with the help of forecast means cross sectional data you will not do the forecasting, or only time series data you can do the forecasting. Yes, we can do the forecasting under the cross sectional data, and we can do the forecasting under the time series data, but the so far as the accuracy is concerned, the kind of sustainability is concerned. So, time series can give you high accuracy, high sustainability in comparison with cross sectional data and cross sectional modeling, so far as forecasting is concerned. So, now after knowing all these techniques, so we will move to the kind of structure. So, that means there are many things we are supposed to know under the time series. So, some of the things are called as components of time series. The here the change which are being in time series, they are affected by many factors, sometimes economical factor, social factor, natural factor, industrial factor and political factors. So, these regions are called typically called time series components, and accordingly we have the structure called as secular trend and seasonal variation, cyclical variations and irregular variations. That means when you are handling time series data. So, since it is actually a structure of day wise information, so, week wise information, monthly information, yearly information. So, obviously there are lots of ups and downs can happen, and there are specific regions for these ups and downs. It may be economical regions, it may be social regions, it may be a natural kind of effect, it may be industrial effect, it may be political effect. So, accordingly, so the particular structure can be divided into for different groups. So, what I have mentioned called as secular trend, seasonal variations, cyclical variations and irregular variations. So, ultimately, so let me give you some kind of hint about these 4 components. So, starting with secular trend, it is the case of increase or decrease in the movements of a time series, and that is what called as secular trend. A time series data may show upward trend or it may show downward trend for a period of years, and this may be due to factors like increase in population, increase in demand, change in technological progress, then a large scale shift in consumer supply or producer supply or consumer demand, something like that. And for examples, population increases over a period of time, price increases over a period of years, production of goods on the capital market of the country increases over a period of years. These are the examples of upward trend, and similarly the sales of a commodity may decrease over a period of time because of better product coming to the market, and this is an example of declining trend or downward trend. So, that means what I have shown you in the last slides. So, when you actually plot or fix these points or visualize this data, you will find the time series reporting may not be in a kind of linear trend. In most of the instances there is means in 99% instances you will find they are in a kind of non-linearity pattern. So, where you will find some ups and some downs, and the question is you have to find out why these ups happens and why these downs happen. So, there is a specific reason for that. Otherwise, if there is no such reasons, then there is a high chance that the particular pattern can follow a linear trend or something like that. So, the beauty of this forecasting is not only to predict the future requirement, but also to find out point out the factors which can cause the uptrend and which can cause the downtrend. So, this is how the kind of structure called as secular secular trend, and then we will have a structure called as seasonal variation. Since it is a kind of time series data, let us start with annual data. When you will talk about the reporting of annual data, it is the sum of monthly data or sum of the weekly data or sum of the day wise data. So, when you are putting a annual data figure, then if you break, then you will find lots of monthly kind of cluster or seasonal kind of cluster. So, like in the last slide we have pointed out there is a ups and downs. So, here in the kind of seasonal breakup, that means technically if you go for quarterly data, you will find there is again ups and downs. So, the seasonal variations are short term fluctuations in a time series which occur periodically in a year. This continues to repeat year after years. The major factors that are weather condition, customs of the peoples, like woolen clothes during winter seasons, and then summer clothes during summer times. So, because of these reasons sometimes these kind of sales will be high, then same summer summer type of clothes, it may be the in a case that the sales will down in the case of winter time. So, that means technically there is a seasonal variation, and it depends upon the type of products, the type of items, or the kind of decision variables, and depending upon the time and the kind of seasonal requirement. So, there is the ups and downs. Against the idea about the time series structure is that to find out what are the factors or the kind of seasonality through which this kind of effect is coming into the picture. Until unless you point out all these factors, then you may not do the better forecasting, or you cannot get a better trend to highlight the kind of engineering problems. So, then the other component is called as cyclical variation. In fact, the previous two are something called as short term kind of fluctuation, but here you will find there is a long term kind of pattern. So, cyclical variations are means it can give some kind of upward or downward movements in a time series, but the period of cycle is greater than a year. So, that means it is actually it is a blockwise something you can call as decadal kind of change, or the best cited example the census data of Indian economics. So, it is actually decadal recording. So, in the decadal recording you will find there is a huge change happening within 10 years. So, you will find some are upward and some are downward. So, that particular change, because of not means that cannot be analyzed annually. So, that will change in a long term interval, and that too in a 10 years intervals, because the data collection mechanism is like that. But it depends the problem to problem, the kind of reporting to reporting, and the kind of requirement to requirement. So, typically this is the kind of structure called as business cycle, and it has kind of ups and downs, and then the kind of structuring. In fact, in this kind of problems, and it is very much actually useful in the kind of engineering problems. If you look into this particular figures, you will find. So, these are all upswings, and these are all called as a downswing, and in between the line is called as trend line, that is actually called as a forecasted lines. So, the idea behind this forecasted line is nothing but called you build a average line altogether, and the average line, this is how the regression mechanism can help you to teach how to get this average line or trend line or forecasted line, and the line which you can actually build through through the econometrics tools or the engineering econometrics tools. So, it will in such a way. So, if it is a kind of data, then 50% of the data will be above and 50% of the data will be below. So, as a result, so you can assume that the particular line is perfectly fit for the prediction and forecasting. If that is not the case, then this particular line cannot be called as best fitted line for the kind of forecasting. So, that is how we should know some of the techniques, the simple one and the complex one, and you have to choose that particular technique which can give you the better forecasting. In such a way, there is no bias at all in the process of the forecasting or the process of picking the trend line as per the particular engineering problem requirement. So, now this is a kind of situation called as seasonal variations, and then we have the kind of structure called as irregular variations, and it is actually very long term kind of scenario. The fluctuation time, that are situation where you will find the floods, earthquakes, wars, these are all major kind of events happening in a kind of scenario, and that is completely irregulars, not regularly happening. For instance, let us say seasonality case, in a particular year it will definitely occur, there is a 99% chance, but the chance of flood in a particular year, the chance of wars in a particular year, chance of earthquakes in a particular year, it is it is not so much kind of mandatory. It may happen, it may not happen, but still in the time series analysis or the kind of forecasting through time series data, this kind of irregularity need to be checked, and then the kind of forecasting accuracy can be pointed out. Certain examples are there, actually we can use different mechanisms. For instance, there is a simple average mechanism is there. So, for instance, there are yearly informations are there for a particular item, say sales or production, something like that, then you like to do the forecasting. So, one of the simple mechanism is called as a moving average mechanism. So, you can go for 3 years moving average, 5 years moving average, 7 years moving average. So, that means whatever data we have here, So, every 3 years, for instance, if you choose 3 years moving average, so every 3 years you find out the average, again next 3 years you can find out average, again next 3 years you will find out average. So, likewise now instead of joining all these actual points, you can now join the average points, then you will find a particular trend line. So, that means you will do actual plotting, and then you will do the plotting through the average. Then the average plotting is called as a trend line, and the actual plotting is called as actual trend. So, the actual trend and the forecasted trend you like to compare. So, you will find if the trend line, forecasted trend line is perfect, then some of the items will be above and some of the items will be below, and by default the above item and below item, if you will sum, then it will give you the kind of zero bias. If that is the case, then this particular trend line will be called as perfect trend line, and then this will be do the better forecasting. Likewise, we can have a different kind of methods to do the forecasting, and this is how the kind of moving average mechanism. So, this is the original data, and these are all called as average data, and this is 3 year 5 year moving average, and again you will go for 3 year moving average, 7 year moving average. So, it is a kind of normalization kind of structure through which you find out the best fitted line as per the particular requirement. So, so far as the application of forecasting are concerned, so you can put n number of ways you can or areas through which you can do the forecasting. For examples, you can go for demand forecasting, sales forecasting, production forecasting, finance and risk management forecastings, operations for management forecastings, economics forecasting, and then industrial process controls and industrial quality controls. So, these are the area where the use of forecasting is very significant, and we can do this forecasting as per the particular engineering problems requirement. And some of the forecasting process are as usual the discussion we have in the regression modeling. So, you start with problem definitions, data collection, data analysis, model selections, model fitting, model validations, robustness checks. As means what we have already discussed, that this choice of a particular model is very essential to do the better forecasting, but whether the particular model is best fitted or best choice, that we can check through model validations and some kind of robustness checks and the kind of sensitivity analysis. Then finally, once you are sure that this model is perfect, that is with respect to both robustness check and sensitivity check, then you can use this particular model for the forecasting requirement. So, this is how the process about the means process about the forecasting, and finally, when you do the forecasting, then we can monitor this forecasting as per the particular engineering requirement. And some of the resources for I mean say forecasting, that means that to know better way to analyze the particular situation. So, you can go through different journals, and you will find plenty of researches or the kind of mechanisms through which you do the forecasting, both in a kind of cross sectional framework and time series framework. So, some of the cited researches, journal researches are Journal of Forecasting, International Journal of Forecasting, Journal of Business Forecasting Methods and Systems, Econometrics, Management Science, Naval Research Logistics, International Journal of Production Research, Journal of Applied Research, and Econometrics. So, like these are the classic journals. You will find plenty of research materials about the forecasting, how to do better forecasting or how to do good forecasting as per the particular engineering problems requirement. So, with this I can tell you the kind of structure of forecasting. And by the way, when we go for forecasting, so the simple mechanism cannot work depending upon the kind of complexity of problems or data ability. In that case, you can use softwares. So, like whatever we have mentioned earlier, some of the econometric softwares specifically useful for forecasting are eViews, Detail, Microfit, CAT, SAGMs, Minitab, and then R, Stata, something like that. So, you can actually do the forecasting accordingly. And then some of the homeworks are there. So, the homeworks are why is forecasting essential part of any engineering, why is it very useful for time series data, not so useful for cross sectional data, something more about qualitative research, the causal forecasting technique, Granger causality, then stationarity issue, and some of the issues very useful for the kind of trend effects, what is the dummy effect, seasonal variations. So, these are all very useful for future requirement, the kind of engineering requirement where we need actually to do better forecasting and better predictions. With this we will stop here. Thank you very much.